Welcome to the JEOL 6060 MRL training video. The instrument is located in SuperCon 21. We have a sample prep area, a sputter coder, and the SEM located here. In this section, we're going to talk about how to prepare your samples for the SEM. The first thing you want to check with your samples is that they are completely dry since they're going in the vacuum chamber. Make sure there's no residual oil or solvent left over. So we're going to review a variety of sample holders that we have available for the JEOL 6060 SEM. The first one that we're going to talk about is for the plain view type samples, which is the most common. You use this large puck and then a base holder to insert it in the SEM. It has a dovetail to slide in and lock and hold it steady. The sample puck is pretty large, so you can fit either a really large wide sample or you can fit multiple small samples. So first we're going to show you how to mount a large sample such as this penny that we'd be using for a top view imaging. You need to use double-sided carbon tape that's sticky and also conductive. Cut a small piece, try not to use excessive amounts of carbon tape. And you can use the tweezers to help you with pressing it down and also peeling off the back side of the paper. Okay, so once you have the carbon tape on, you need to make sure you press the sample and make sure it's secure, and you can do that with tweezers on two sides of it, and then turn the sample puck over and make sure the sample is actually secure. Next, you need to insert the puck into the base, and it has some set screws at the four corners. You only need to do 2 catty corners and then tighten the set screws. Don't overly tighten them. We don't want to strip the screws, but you just need to make sure it's tight enough that it is secure. And you can use this little red screwdriver that we leave on the table to do that. And after you tighten the screws, you're going to flip it over and make sure the sample and the puck is both secure. Okay, so once you have this, you're ready to put it in the SEM. So we also have some additional types of sample holders. This one has clamps if you don't want to use any kind of tape. The limitations are the sample needs to be sturdy enough to be held down by the clamps, but also not too thick because the clamps can't hold a very thick sample. So thin but strong. Once you tighten the clamp screws down, you would tighten the puck in the base just like you did the other one. The next sample holder is for looking at samples that you want to see the cross section and they've been cut. So you have this clamp that you can open, and if your sample is strong enough to be held by the clamp, you can just slide it in between the clamp and let it hold it. If you don't think it's strong enough, you can also use a piece of double-sided carbon tape and stick it to the back side of the clamp, which is nice and flat, but also holds the sample straight. And so you can stick your sample to that side as well. The bottom of this holder also has its own dovetail, so once you mount your sample, you can directly slide it into the SEM holder. You don't need the base. In addition, we also have this pre-tilted sample. So you can see it's already cut at an angle. This avoids having to tilt the stage and risk breaking the SEM. It's tilted at 45 degrees, so you can use double-sided carbon tape and stick your sample at a predefined angle. In addition, this sample holder is also a little bit too small for the base, so you'll have to use double-sided carbon tape to hold it in the base. We also have an adapter, so if you buy these little small SEM sample pucks from the MRL storeroom, you can keep these and then bring them with you. You can use our adapter, and it has 4 slots, so you can use set screws to tighten and hold the piece in each one of these. They're also labeled so you can keep track of similar samples and know which spot it's located when you're imaging in the SEM. So after you mounted your sample with double-sided carbon tape, you would simply set it in, make sure it's flat and not poking out the bottom, and then use one of the 4 set screws to tighten it and secure it. So I'm just showing you one for now, but once you had the samples that you want to look at, you would take the base and put the sample holder in it. And just like before, make sure it's secure and tighten the set screws at the caddy corners. And then you would check that it's secure by flipping it over and making sure that the sample and the holder are both tightened correctly. So in addition, we also have a holder for looking at these T sample holders, T-shaped, and you can buy these in the MRL store as well. So this holder can also hold more than one of these T-shapes, and it has small set screws to tighten within it as well. And just like before, it uses the base, so you would mount your sample, put the T in, secure it with the set screw on the side, and then you would secure that sample holder in the base as well. So after you mount your sample, there's a very critical step you must perform every single time. Take the magnet that we have provided in the sample prep area and make sure there is nothing magnetic in your sample. Even if you think you know there's no magnetic particles or anything, just take the magnet and hold it over and make sure nothing comes loose. This is critical because if you put magnetic samples into the SEM, there's a possibility it can cause damage. And so if that happens, you can lose privileges to all the SEMs. So this is something we prefer that you check every single time. If you do want to look at a magnetic sample, you are required to speak to staff first. So another type of difficult sample you may want to work with is powders in the SEM. So if they're not pre-mixed into some type of epoxy, you can bring a loose powder, but you're going to need to use this plain view puck, have the double-sided carbon tape already mounted onto it, and then you'll sprinkle a very small amount of particles because if you want to look at individual particles, you need a small amount. And then you must press them gently into the tape so they make good contact. Make sure you use the air gun to blow away any excess particles from the surface that's not bound to the tape, and then secure the puck into the base as we showed you previously. Now we're going to show you how to use the sputter coater for non-conductive samples. First, you're going to begin by opening the argon tank, and there's a few valves, so you only want to open the main valve to open it. The pressure settings are already set for you, so you can use the right-hand rule to figure out which way to turn the valve to make sure it's open. Next, you're going to take your sample that's already on the puck. Make sure it does not include the holder or the base. And then you're going to take as many samples as you want, as you can coat multiples in one setting to make it efficient. Put them inside the glass chamber. Even the small pucks can go in. Once you have the samples in, then you will shut the lid. Make sure that everything is centered, including the lid and the chamber are all aligned. So now we're going to begin the operation of the sputter coater. You turn the on button. Adjust the timer settings here. 0.5 to 1 are usually good enough for most samples. Next, you're going to hold the lid to the chamber down with one hand to make sure it's sealed, and then press start to begin pumping. Then press the pump hold button and wait until the pressure reaches 0.5 torr, which may take several minutes. Once the pressure reaches 0.5 torr, press the pump hold button again. The rest of the system will run automatically. Once you see the purple light come on, the plasma is coating your sample. If needed, check the current is close to 10 milliamps. If it's off, you can adjust the deposition knob to get it to approximately 10 milliamps. Once the coating is finished, the system will automatically vent the chamber. Now that it's finished, you can take your samples out. And you can see there should be a thin metallic coating on the surface. If the coating is not enough, you can rerun the system again. When you're finished, turn it off, close the lid, leave the system vented for the next user, and make sure you close the argon tank. In this section, we're going to talk about how to load your sample into the SEM. After your sample prep is complete, you are ready to move to the SEM. First, make sure you hear that the pumps are working and running in the background. Then make sure that the software is turned on. Check the IR chamber scope is turned on with 2 power buttons here and here. And now we're ready to load your sample into the SEM. So first check that the front of the instrument, you see the green light is lit up on the evac button. So that means that we're ready to vent, so go to the software and click the vent button. The light should now start blinking on the vent button on the front of the instrument. Once the blinking stops, then you are ready to open the door. So in order to open the door, gently grab the sides of the door, not the knobs, and gently slide it open. Now we're ready to load the sample into the SEM. So you can see the sample that we've preloaded that's already on the base, has its dovetail slot on the bottom. So we're going to mount the flat side towards the flat wall of the sample holder in the SEM. You can see that part here. So gently slide it on until it reaches the stopper, and then it's fully all the way loaded. Next, you're going to need to measure the height of your sample. So we use the height gauge here. It's preset for the working distance of this SEM. So slide it on and then use this top knob here to raise or lower the sample to about 10 millimeters working distance, which is the bottom of the ruler on the height gauge. And you can check from either side if your sample is close to the bottom of the ruler, and then readjust the height as needed. Once you have the sample height where you want, you are finished. One reminder is that you're not looking at just the lowest point of your sample, you're looking at the highest point of your sample when you measure the height gauge. Now you can close the door. Once it's fully shut, we're ready to evac the system again. So to do this, you need to press one hand on the door to help it create a seal. And then we're going to go to the software and click the evac button. Continue holding the door with your hands until it changes to evac. Now you can let go. Continue to wait for another minute or two to get a good vacuum. Now we will discuss how to operate the SEM. So now we're looking at the software. We're going to start by setting some parameters. So at the bottom of the screen, select your desired accelerating voltage. So for this sample, we're going to select 20 kV, and we'll double click to choose that. Next, we're going to check our working distance is set to 10 millimeters. And then check that your signal is set to SEI at the bottom of the screen. In the top left corner, check that the HT says ready, Now we can close this window and click HT to turn on the high voltage. There should be some signal showing up, and you can see here, we can see something in the window. If you're having a hard time seeing anything, you can go up here to the top and press the ACB button to adjust the contrast and brightness. So we need to find a region of interest on the sample that we want to look at. We're a little zoomed in, so we can click this View button to demagnify. And now we can kind of see a wider area. So on the front of the SEM, we're going to turn the rotate knob and actually move the sample until we find the area that we're looking for. So that you have a better view, these are the knobs that we're actually using to move the sample on the front of the SEM. This first one is moving the sample in X, now the Y, and this R is the rotate, which is what's rotating the sample on the screen. So this is the sample region that we want to take a look at. So what we want to do now is do a rough focus on the image. So we'll turn the coarse button on, and you can turn it to the left or right and determine what is the best view for your sample. So now that we have the sample area that we want to look at, we're ready to begin the alignment. So to do this, we're going to go to the top right corner, click the gun button to open the first window. And to begin the alignment, we're going to first need to zoom in to between 1 and 5 kAx. You can use this magnification knob to turn and zoom in. It's a little blurry, so we're going to adjust the coarse focus as we go. Okay, we'll zoom in some more. Okay, so this should be fine. So to begin the alignment, we're going to set the spot size for the tilt adjustment. We're going to set that to 20. Now we're going to press the ACB button. Okay, so what we're looking for is the brightest image possible. So we'll slide the X slider down until it gets dark, and then slide it the other way until the image gets brighter. And then keep going until it gets dark again, and then go back to the maximum brightness. Repeat this for the next slider, the Y. Okay, for the shift adjustment, we're going to move the spot size all the way back up to 60. And you can see the image looks a little saturated right now, so we're going to want to press the ACB button and bring that contrast back down to a good range. Okay, so we're going to repeat the same procedure as before. You're going to slide the sliders down until it gets dark, and then go back and look for the brightest image. Go a little past that until it gets dark again, and then go back to the maximum brightness for X, and then we'll repeat it for the Y. Okay, so now we're ready to do the filament heating, so we're going to adjust the spot size to 50. So at the top, this is the one we're not going to drag this slider, so instead we're going to click the up and down arrows one at a time. So we'll click down until the image begins to get dark. Now we're going to click up until the image brightness saturates, and then you're going to want to stop clicking. Once it saturates, then we're going to click down about 4 times and this should be the ideal working spot. So now that these steps are complete, we're going to bring the spot size back down to something we're going to use for imaging. So 35 is going to be good for this sample. Now we're going to check the objective aperture centering. This is especially important for higher magnification. So to do this adjustment, we need to go to a higher magnification. The coarse button is still checked, so we can use the magnification to move in pretty quickly. So we're going to a little bit higher than 5K magnification. You can adjust the focus as needed. Now we're going to go up to the top of the screen and we're going to click the wob button. You can see that there's some image shift. It's wobbling a little bit to the left, a little bit up and down. So we want to correct this. So on the instrument, there are two knobs that are going to correct the X and Y directions separately. So first we'll turn the X, and then you'll see a lot of movement in the Y direction. So then we'll move the Y and correct for that direction. And remember, we're only making very, very tiny turns. As you can see here, these are the two knobs that we're turning to make these adjustments. So take your time, and when it's finished, it should look something like this. So it's not excessively moving in X or Y. It's kind of just focusing in and out of the screen, not really moving in either direction. Okay, so the last step is to check your fine focus and correct any astigmatism. So you can see on the panel here, these two knobs are currently controlling the contrast and brightness, but if we click the stig button, now they're controlling the X and Y of your stigmatism. You can also come to the software and you can click focus or stig X or stig Y, and then you see the slider on the left side can be moved up and down with the mouse. This is a very quick adjustment to look for the best quality image, and you're trying to correct focus, and then if you click the stig X or stig Y, you can correct them as well. And we're just dragging the mouse up and down. So once you have the best correction, you can see the image is very clear, and this is a very high magnification. So now we're ready to just find an area of interest and take an image on your sample. And the alignment is complete. So remember, if you're looking for a region of interest, you can use the magnification button and you can zoom in or zoom out. Then you can use the rotation knob. You can also move the sample in the X and Y direction to find a region that you're specifically interested in. Once you find a region that you're happy with, turn the coarse button off, and then you can use the knob or you can use the software to do a fine focus adjustment for whichever magnification that you're at. One thing to remember that's kind of hard to see is that when I click on the software on the focus or stig X or stig Y, I'm holding down the mouse button as I move the mouse up and down, looking for the best quality image. So once you're happy with all the image adjustments, we're currently in scan 2. So we want to move to scan 3 or 4 for a high quality image that we want to save. And they're going to scan a little bit slower. And for a final touch, you can use the knobs or the software to make sure the stig is off, and then you can adjust the contrast or the brightness of your image. Once you're happy with whatever adjustments that you've made, you can also use the ACB. Then you are ready to click the freeze button, and at the end of the scan, in the scan 3, it will save the image and stop scanning. Okay, so once it stops, you can see the parameters at the bottom of the screen, and then at the top you'll see, at the top of the image, you see the save button here. So you can click save, navigate to the user folders. You can create your own folder or a new folder for whichever day, and then save your image in your actual folder. So once you're done with that, you can click cancel and go back to the live view, We're still in scan 3, so if you're ready for looking for another spot, you can go back to scan 2, or you can hit the view button to zoom completely out and go to a new sample. Okay, so once you're finished looking at all the samples that you want, we're ready to end the session. So to do that, we'll go to the top left of the screen and click the HT on to turn the high voltage off. And after that, we're going to actually wait 2 minutes before we proceed to the next step. Okay, so after 2 minutes, we can click the sample button at the top right, and now we'll click the vent. You can see on the front of the instrument, the vent button would start blinking, and we'll wait until that blinking stops before we open the door. Okay, so fast forward, now the venting has stopped, we're ready to slide the door open. So be very careful and gentle. You can turn the sample back to an easy angle to slide the dovetail off. Gently pull your sample parallel to the sample plate. Do not pull straight up on the sample. Okay, push the door back in. And just like before, you're going to hold the door and then we're going to press the evac button. And we'll wait until it says evac before we let go. And then before we leave, we're going to make sure the HT actually says ready, and that will be your final step. All right, so now that we see the HT is ready, everything is complete.